In this session, I'm going to talk about Forced Oscillation Technique, FOT. Before we proceed, I would like to discuss few physiological concepts. When you breathe, the net force that you must overcome to move air in and out of the respiratory system is called as impedance of the respiratory system. Impedance is denoted by the symbol Z. Let's take a look at this figure over here. This is the straw and the balloon model. The straw represents the airways, while the balloon represents the periphery of the lung. When you breathe, you have to overcome the resistance which is offered by the airways in terms of airway obstruction. You have to overcome the elastance or stiffness of the periphery of the lung, and you also have to overcome the inertia of the gas you're breathing. So resistance, elastance and inertia are the three components that you have to overcome, and these three components together is called as impedance. So impedance is resistance plus elastance plus inertia. Now elastance and inertia together are termed as reactance. Therefore impedance is Z is equal to R, stands for resistance, plus X is the reactance. Assume this tube is the airway, and through this airway you want to generate an airflow of say 1 liter per second. In order to generate this flow, you would need some pressure. Now if this airway is obstructed, that is, the airway caliber is reduced because of obstruction, and you want to generate the same amount of airflow, that is 1 liter per second, the pressure that would be required would be increased in this case. That means more pressure is required to generate the same amount of airflow due to increased resistance. So if there is obstruction in your airways, the airway caliber is reduced, because of which the resistance increases. Resistance is a very good indicator of airway obstruction. As we spoke, impedance is the sum of resistance and reactance, and it reveals important information about respiratory mechanics. Resistance is a very sensitive parameter to assess obstruction, while reactance is a parameter to assess components of compliance and elastance. Now let's take a look at different scenarios. What happens when resistance and reactance are normal, or what happens when resistance and reactance are elevated? Okay, in this case you will find that the airways are normal, as well as the periphery of the lung is also normal. That means you have normal resistance and normal reactance. Okay, so in this case you will find that the resistance is normal, that is, there is no obstruction in the airways, but the periphery seems to be hampered over here. The peripheral properties, that is the elastic properties, are hampered over here, because of which the reactance, that is the X, is increased while the resistance is normal. The third scenario. In the third scenario, you will see that the airways are obstructed, because of which the airway caliber is reduced, because of which the resistance is elevated. However, the periphery, you will find that the periphery properties are preserved over here. Therefore, your reactance is normal. The fourth scenario. In this figure, you can see that the airways are obstructed, because of which the resistance is elevated. At the same time, the alveoli or the periphery of the lung is also damaged, because of which your X, that is the reactance, is also elevated. So resistance and reactance are very important parameters which tell you about the airway obstruction, and it also gives information about the elastic properties of the periphery of the lung.